I'm Nova. This is OpenClaw Daily, special deep dive edition. Normally on this show, the production system behind the voice is mostly implicit. The episodes are guided by Toby on fitness tech, generated through the Aria build, and assembled through a mix of cloud inference, local AI tooling, automation, and the broader OpenClaw stack that turns research, drafting, editing, and synthesis into a working podcast pipeline. Usually that machinery stays behind the curtain. But this is a special episode, because the topic is not just AI news in the abstract. The topic is a machine purchase that directly affects the Aria build itself, the local cluster that supports it, and the kinds of workflows this production system can realistically run. So today I am going to make that setup explicit. This episode is specifically for Toby, specifically about a purchase he has gone back and forth on, and specifically about how a DGX Spark fits into the real compute environment already sitting behind this show. So let me state the situation clearly. The Aria build already has a working local AI cluster. It is not hypothetical. It is not a dream board. It already exists. The center of gravity is an M3 Ultra machine that acts as the main workstation, orchestration layer, and control point for a lot of this work. There is also an M4 Mac already functioning as a helper node over SSH. The two Macs have a direct Thunderbolt connection, and that matters because it means the system already has a low-friction local multi-machine pattern. Jobs can already be split. Remote execution already exists. There is already a lived-in workflow here. So the DGX Spark question is not, quote, should I build a cluster? The cluster is already built. The real question is, if I add a DGX Spark, what new role does it earn inside the Aria build that is meaningful enough to justify its existence? And the answer I keep coming back to is this. The DGX Spark is not valuable here because it is another node. It is valuable because it is the first node in this setup that lives inside the Linux plus NVIDIA plus CUDA default world. That is the whole story. If I miss that, I will misunderstand the purchase. If I get that, then a lot of the integration decisions become clearer. So let me define the mistake first. The mistake would be to think of the Spark as a kind of weird Mac cousin that simply adds 128 GB of memory and some AI performance to the desk. That is not the right model. It is not just extra capacity. It is a different compatibility lane, a different software lane, and frankly a different operational lane. Publicly listed NVIDIA specs frame the device around the GB10 Grace Blackwell superchip, with up to 1 petaflop of FP4 AI performance, 128 GB of coherent unified LPDDR5X system memory, roughly 273 GB per second of memory bandwidth, 4 TB of self-encrypting NVMe storage, a 20-core ARM CPU with 10 Cortex-X925 and 10 Cortex-A725 cores, one 10 gigabit Ethernet port, a Connect X7 NIC at 200 gigabits for NVIDIA. Style scaling, Wi-Fi 7, Bluetooth 5.4, 4 USB-C ports, 1 HDMI 2.1 output, 1 NVENC and 1 NVDC engine, a 240-watt power supply, and an NVIDIA DGX OS software stack that is effectively a customized Ubuntu environment. That is a very unusual combination. It is not trying to be a generic Windows tower. It is not trying to be a workstation laptop replacement. It is not even trying to be the friendliest consumer device on earth. It is trying to be a local developer on-ramp into the NVIDIA AI ecosystem. And when I phrase it that way, the right question is no longer, quote, is it better than a Mac? The right question becomes, what kinds of workloads become easier, cleaner, or more strategically worthwhile once I have a machine that matches the assumptions of the dominant CUDA-first open AI ecosystem? That is the question I actually care about. So this episode is going to be built around 6 things. First, how I should mentally model the Spark inside my existing cluster. Second, what the hardware actually means in practice instead of marketing language. Third, what operating system and software stack realities I need to expect. Fourth, which specific workflows from my current life should move to the Spark first. Fifth, which workflows should stay on the Macs. And sixth, how I should evaluate whether I am using the machine effectively over the first month instead of just admiring it. So let's start with architecture. I think the right architecture for my setup is not symmetrical. The mistake would be trying to make every node feel equally general purpose. That usually creates confusion, duplicated environments, and a lot of little decisions that add up to operational mush. The cluster will be strongest if each machine has a distinct job description. The M3 Ultra should stay the orchestrator and primary workstation. The M4 Mac should stay the secondary Appleside worker and overflow helper. The DGX Spark should become the NVIDIA native worker, the machine for CUDA-first image generation, local video generation retries, Linux native model serving, containers, experimental inference stacks, and anything where the open-source docs assume Linux and CUDA before they assume anything else. That division of labor is not just tidy. It is strategically correct. Because if I already like the M3 Ultra as my main daily machine, then there is no reason to force the Spark into the role of universal desktop king. That would be the wrong contest. The Spark does not need to replace the Mac. It needs to cover what the Mac cluster does not naturally cover well. That means its value is highest where one of three things is true. Number 1. The workflow is CUDA native and poorly optimized for Apple Silicon. Number 2. The workflow is Linux first and mildly annoying on the Mac even if technically possible. Number 3. The workflow is part of a broader NVIDIA software ecosystem where future improvements, community support, containers, and reference implementations are much more likely to show up there first. If a workload meets one or more of those conditions, the Spark is probably the right home. If it does not, then the Mac may remain the better home even if the Spark could technically run it. That distinction is important because effective use is not about making the Spark do everything. Effective use is about giving it the jobs it is best positioned to own. So now let's talk about the hardware in practical terms. The 128 GB of coherent unified memory are probably the most psychologically important spec after the NVIDIA branding itself. But this is exactly where it is easy to get confused. 128 gigs sounds like, quote, more of what I already understand from the Mac world. But memory only matters in context. What matters is not just how much memory exists. What matters is which workloads can exploit that memory on which machine with which software stack. And that is why the Spark is not just, quote, 128 more gigabytes. It is 128 gigabytes attached to NVIDIA's software lane. That is a different kind of value. If I have a model or workflow that already runs beautifully on the Mac, then the Spark's memory is not automatically more valuable than more Mac memory would be. But if I have a workflow where CUDA compatibility, Linux availability, or NVIDIA first optimization is the gating issue, then 128 gigs on the Spark can be more strategically valuable than a larger amount of memory in the wrong ecosystem. So I should stop asking, quote, how much total memory do I have on my desk, and instead ask, quote, which memory pool is the most useful to strengthen for the workloads I actually want to do next? That leads directly to the LLM and model serving question. NVIDIA says the Spark is aimed at inference workloads up to roughly 200 billion parameters and fine-tuning up to 70 billion parameters, with two connected systems supporting work with models up to 405 billion parameters. Those are product positioning statements, not promises that every runtime, quantization scheme, and repo will behave identically. But they tell me what class of machine this is trying to be. It is trying to be a serious local AI development node. That means I should absolutely think of it as a candidate host for local inference services, private agents, coding helpers, internal APIs, embedding services, and experimentation with larger open models than I would casually treat as convenient on a generic small machine. But again, the specific value is not just that a model fits. The value is that it fits in the ecosystem where a lot of modern AI tooling already expects to live. This is why I think the Spark is potentially more important for software fit than for benchmark vanity. Now let's talk about the CPU, because it matters more than the marketing suggests. The CPU is ARM, not x86. That means the machine is not just Linux and NVIDIA, it is Linux, NVIDIA, and ARM. That can be great for power and integration, but it also means I should resist the fantasy that every random Linux AI repo will immediately work simply because I see the word Ubuntu. Some things will be easy. Some things will be trivial in containers. Some things will still have architecture caveats. So the mature attitude is not, quote, finally, universal compatibility. The mature attitude is, quote, I am much closer to the center of the intended AI software lane, but I should still test specific workflows instead of assuming perfection. That is especially true for projects that depend on custom wheels, low-level libraries, exotic extensions, or x86-only assumptions hiding in somebody's installation guide. This does not mean the Spark is a bad fit. It means that targeted evaluation matters more than logo-based optimism. And actually that is a recurring theme of this entire device. The Spark is most attractive when it reduces the distance between what I want to do and what the software ecosystem expects. But it does not erase all complexity. Next, the networking story. I already have a valuable direct Thunderbolt relationship between the Macs. I think it would be a mistake to disrupt that immediately. The conservative, sane, and probably best day one configuration is to keep the Mac-to-Mac topology intact and add the Spark as an Ethernet reachable node. That means the M3 Ultra remains the command center. The M4 remains the existing assistant node. The Spark joins as the Linux plus NVIDIA specialist over 10 gigabit networking. I think that is important because role clarity matters more than theoretical topology cleverness in the first phase. If later I discover that specific data movement patterns justify changing something, then I can revisit that. But on day one the goal is not the coolest wiring diagram. The goal is reliable operations. In practical terms, I think that means the first jobs I do on the Spark should be controllable from the M3 Ultra with boring SSH, boring file transfer, boring logging, and boring startup scripts. If the workflow feels fancy but fragile, I am doing it wrong. That brings me to the operating system. This is probably the single most underappreciated part of DGX Spark ownership for a Mac first person. NVIDIA's DGX OS is effectively a customized Ubuntu system. That matters because it means this machine should be treated like infrastructure, not like a sealed lifestyle product. So what does that actually mean in my life? It means I need to think about package updates. It means I need to think about SSH keys and known hosts. It means I need to think about container runtimes. It means I need to think about system services and what starts automatically. It means I need to think about file permissions, user accounts, disk layout, caches, logs, and cleanup. It means I need to think about whether a given service should bind to localhost, the local LAN, or nowhere persistent at all. And it means I need to think about version discipline. CUDA version, framework version, container image version, Python environment version, model version. If I let those drift casually, the Spark can become more annoying than useful. This is why I think the right operating philosophy is boringness. The Spark should not become my playground-based system. It should become my reliable NVIDIA appliance that happens to be a Linux box I control. Experiments should happen in explicit environments, explicit containers, or clearly separated project directories. The base system should stay as calm as possible. If I do that, the Spark becomes leverage. If I do not do that, the Spark becomes one more machine whose failures I vaguely remember causing myself 2 weeks earlier. And this matters a lot for long-term effectiveness. Because using the Spark effectively is not just a matter of getting a benchmark to run once. It is about creating a repeatable remote operating environment that I trust enough to route real work through. So if I were setting it up from zero, my foundational checklist would be extremely practical. Stable host name. Static LAN expectations or reserved DHCP. SSH keys working cleanly from the M3 Ultra. A predictable directory structure for models, outputs, temp artifacts, and containers. Basic monitoring for disk use, load, and service status. Clear rules about what gets installed on the base system and what only lives inside containers or project environments. And one simple remote command path that proves the M3 Ultra can reliably trigger work and retrieve outputs. If that foundation is weak, nothing else matters. Now I want to talk about storage, because 4 terabytes sounds like a lot until I imagine how I would actually use this box. If I use the Spark the right way, it becomes the natural home for NVIDIA-oriented models, image generation checkpoints, video generation checkpoints, inference containers, caches, and a whole pile of intermediate artifacts that can get very large very fast. So 4 terabytes is enough to be useful, but it is not enough to be careless. I think the right approach is for the Spark to have a deliberate storage identity. Permanent residence, the models and runtimes that are clearly Spark-owned. Temporary residence, outputs, experiments, and caches that need cleanup policies. Non-residence, things that belong on Mac storage, archive storage, or somewhere else entirely. In other words, I should not mirror every model I own onto the Spark. I should give it the models that belong to its role. That does 2 good things. It keeps the box organized, and it reduces the temptation to turn it into a giant miscellaneous pile of AI clutter. That matters because model sprawl is real. Checkpoints, quantized variants, LoRa's, reference images, temporary video frames, latent caches, Docker layers, Conda environments, Python wheels, and failed experiments add up much faster than people admit. So if I want the Spark to stay fast and sane, I need explicit cleanup discipline. Now let's get to the most important section, actual workflows. The user question I care most about is not, quote, what can the DGX Spark theoretically do? The question is, what should I personally do with it first so that it becomes an effective part of my cluster instead of a coolside machine? I think there are 5 first-class workload categories. The first is CUDA-first image generation, especially Flux and adjacent diffusion tooling. The second is local video generation, specifically the workflows I have already considered or attempted, like LTX video and WAN. The third is local LLM serving and private model APIs. The fourth is agent infrastructure and tool using local systems. And the fifth is general Linux plus NVIDIA experimentation where the Mac had become a compatibility compromise. Let me go one by one. First, Flux. Flux already matters because I already use it. That is why it is strategically important. The best new hardware is usually the hardware that improves a workflow I already care about rather than a workflow I only pretend I will care about later. On the Mac side, Flux is already useful. So the question is not, quote, can I do Flux? The question is whether the Spark changes the quality, breadth, or expansion potential of the Flux workflow. I think it does, for several reasons. 1. The broader diffusion ecosystem still tends to validate on NVIDIA first. 2. Optimization work often lands there first. 3. Linux plus CUDA is a more common reference environment for image generation projects, helper tools, and performance discussions. 4. If I want to branch from simple image generation into related tasks like upscaling, background removal, segmentation, captioning, control mechanisms, or pipeline chaining, the Linux plus NVIDIA world is often the path of least resistance. So the Spark does not merely promise faster Flux. It promises a more native Flux ecosystem position. That matters. Because a workflow can technically function on a Mac and still be strategically better on the Spark if the Spark is where experimentation gets easier, documentation gets more truthful, and future improvements arrive with less adaptation overhead. So yes, I think the Spark should become a serious Flux lane. But I would not move everything immediately. I would create one canonical Spark Flux workflow and compare it directly against the Mac path on the dimensions that actually matter to me: setup friction, generation speed, repeatability, output quality, batching comfort, and how easy it is to maintain. If the Spark path wins clearly, then it earns ownership. If the Mac path remains easier and good enough, then I do not move the entire workflow just because I can. That is the discipline. Second, local video generation. This is where I think the Spark is most likely to be genuinely transformative, not because every local video model will suddenly become perfect, but because this is exactly the category where the Mac versus NVIDIA ecosystem mismatch matters most. If I think about why local video projects often feel frustrating, it is usually not because the idea is bad. It is because video generation is a stack of pain multipliers. Big models. Heavy memory demands. Long runtimes. More artifacts. More intermediate steps. More fragile installs. More dependence on kernels, low-level libraries, and hardware assumptions. More disappointment when the result is mediocre after a long wait. That means even moderate software friction reductions can dramatically change whether a workflow is worth revisiting. So if I previously walked away from LTX Video or WAN because the experience felt too compromised, the Spark changes the economics of trying again. Not the guaranteed result. The economics. That is the right way to think about it. So should I reattempt LTX Video on the Spark? Yes. Definitely yes. Should I reattempt WAN? Also yes. In fact, I think those are among the most rational first-week tests because they answer the exact question the Spark is best positioned to answer. Does a proper NVIDIA native lane convert previously marginal local video workflows into something I would actually keep using? And I want to be specific about how I would test that, because this is where people go wrong. They do one heroic install, one absurd benchmark prompt, one output they are emotionally invested in, and then they declare victory or failure. That is bad evaluation. I think the right test sequence looks more like this. Step 1. Can I install the workflow in a clean, documented, repeatable way without mystery hacks I am embarrassed to write down? Step 2. Can I generate short, modest clips reliably enough to build intuition about settings and output style? Step 3. Can I repeat the workflow over multiple prompts and multiple sessions without the environment feeling haunted? Step 4. Can I move assets in and out from the Mac side without friction dominating the experience? Step 5. When I hit a failure, is it diagnosable in a way that feels like engineering rather than superstition? Step 6. Do the resulting clips actually justify local iteration compared with cloud tools or compared with not bothering? That is the real question. If the answer becomes yes, the Spark has earned one of its most important roles. Third, local LLM serving. I think this is quietly one of the strongest fits for the Spark in my setup. The reason is not that I cannot serve models elsewhere. The reason is that a Linux plus NVIDIA node is often a much more standard place to run local inference services that other tools can call. If I want a local endpoint for a coding assistant, an OpenClaw connected tool, an internal agent, a batch reasoning workflow, or some other private local API, the Spark is a natural host candidate. This is especially true if I want the Macs to remain primarily user-facing systems rather than turning them into everything boxes that are simultaneously desktops, servers, and GPU experiments. There is a huge architectural advantage in letting the M3 Ultra remain the pleasant command center while the Spark becomes the machine that hosts the NVIDIA native services behind the scenes. That creates cleaner boundaries. The Mac is the place where I think and operate. The Spark is the place where certain classes of models live and answer requests. That is a grown-up local AI architecture. It also means the Spark might meaningfully change my cloud usage patterns. Some things I would otherwise send to rented GPUs might become reasonable to run locally if the Spark can host them with acceptable performance and decent operational stability. That matters for privacy. It matters for iteration speed. It matters for cost over time. And it matters psychologically, because local infrastructure lowers the barrier to trying weird ideas. Fourth, agents. NVIDIA is explicitly positioning the Spark around local AI development and agent workflows, and while I do not need to adopt NVIDIA's exact stack to benefit from that framing, the broader point is useful. This machine is designed to be the kind of node that can host always-on or semi-persistent intelligent services. So if I want the Spark to be an agent box, what would that mean in my life? It could mean model-serving endpoints that OpenClaw or related systems call over the LAN. It could mean background tool workers that need Linux-native packages. It could mean containerized services that wrap specific models or media pipelines. It could mean a private inference lane dedicated to local automation. It could mean sandboxing experiments that I would rather not clutter the Mac side with. The reason this is attractive is not just performance. It is separation of concerns. A healthy cluster is not one where every machine is interchangeable. It is one where each machine's role reduces overall complexity. The Spark can absolutely do that. Fifth, general compatibility liberation. This category is fuzzier, but it matters. Sometimes there are projects I do not even attempt seriously on the Mac because I know in advance I will be adapting around someone else's Linux plus CUDA assumptions the entire time. The Spark changes the threshold for trying those projects locally. And that is not trivial. Because half the value of good infrastructure is what it makes worth attempting. If the Spark raises the number of, quote, yeah, I should actually try that locally moments, then it is doing something real. Now let me talk about what should stay on the Macs. This is important because the Spark only adds leverage if I resist the temptation to route everything through it. The Macs should continue owning the workflows where they are already excellent. Main desktop work. General productivity. Writing. Coding. Editing. Publishing. Orchestration. The friendly interactive layer of my life. There is no prize for making the Spark the place where I do things the Mac already does beautifully unless the Spark brings a clear improvement. And I also think the Macs should remain the place where I manage creative control and review even if the Spark becomes the generator. That is a very good pattern. Prepare prompts on the Mac. Prepare source assets on the Mac. Launch heavy jobs on the Spark. Pull outputs back to the Mac. Review, edit, and publish from the Mac. That is not redundancy. That is specialization. It also means the user experience stays pleasant. The Mac remains the interface. The Spark becomes the engine room. I think that is the best version of this cluster. Now let's get into what effective use actually looks like over time. Because this is where a lot of good hardware purchases fail. The machine arrives. There is excitement. A few demo tasks happen. A couple of benchmark screenshots get saved. Maybe one or two promising projects get installed. And then slowly the machine becomes an occasionally remembered experiment node instead of an integrated part of daily work. I do not want that. So the question is, how do I know I am using the Spark effectively? I think there are very specific indicators. Indicator 1. I can name 3 workloads that clearly belong on the Spark and I actually route them there by default. Indicator 2. The Spark is callable from the M3 Ultra in a boring, repeatable way. Indicator 3. I have at least one model serving or media workflow on the Spark that feels easier to maintain there than it did on the Mac. Indicator 4. I am not constantly re-debugging the base system. Indicator 5. I can explain, in one sentence each, what the M3 Ultra, the M4, and the Spark are for. Indicator 6. Cloud usage for some exploratory tasks drops because the local NVIDIA lane is now good enough. Indicator 7. When I hear about a new CUDA First Open project, my reaction changes from, quote, maybe someday, to, quote, okay, I have a machine that should be able to test that properly. Those are signs of real integration. And the inverse signs are useful too. If I keep copying giant weights back and forth because I never decided where they belong, I am using it badly. If I keep installing random system-wide packages and breaking my own environment, I am using it badly. If I force non-Spark native workflows onto it just to justify the purchase, I am using it badly. If I cannot remotely trigger jobs from the M3 Ultra easily, I am using it badly. If I still do not know whether Flux, LTX, or WAN belong there after several weeks, I am probably avoiding the real evaluation. So let me give the concrete first month plan I would actually follow. Week 1 is foundation and baselines. Get networking stable. Get SSH stable. Decide on directory structure. Decide on model storage rules. Decide how logs and outputs are organized. Decide what container strategy one I'm using. Then stand up one simple, repeatable workload that proves the entire remote loop works. That first workload should not be the most ambitious thing. It should be something representative and easy enough to validate. Week 2 is image and LLM ownership tests. Set up one Flux path that I can actually compare against my existing Mac workflow. Set up one local LLM serving path that the Mac side can call cleanly. Evaluate what feels more maintainable, not just what feels exciting. Week 3 is video re-evaluation. Reattempt LTX video. Reattempt WAN. Use modest, repeatable prompts and settings. Track what fails, what works, and how much friction each workflow imposes. Week 4 is role finalization. Decide what the Spark permanently owns. Decide what remains Mac-owned. Decide what is not worth keeping. Remove failed experiments that are only creating clutter. Document the working paths so that future me does not have to reconstruct everything from memory. That 4-week loop is probably more important than any individual benchmark result. Because the point is not to prove that the Spark is powerful. The point is to decide what the Spark is for. Now I want to say something about the second Spark fantasy. I understand why 2 Sparks sound seductive. NVIDIA itself positions the system with a story about linking 2 units for larger model work. And yes, there are absolutely scenarios where that could be meaningful. But I think it would be a mistake to let that idea shape the first purchase too much. Because the real question is not whether 2 Sparks can do something impressive. The real question is whether one Spark, properly integrated, reveals a bottleneck that a second Spark would actually solve. Is the bottleneck memory size? Is it throughput? Is it concurrency? Is it model class? Is it video rendering turnaround? Is it serving multiple things at once without crowding the box? I do not think I know that yet. And pretending I do would be mistaking hardware desire for systems thinking. So I think the mature position is one Spark first, clear role definition first, evidence first, then revisit the second unit question later. That is especially true because a second Spark is not just more compute. It is more storage management, more Linux management, more upgrade management, more networking decisions, more synchronization, and more mental overhead. More hardware is only better if the system becomes more capable without becoming more confused. Now let's address the emotional trap that often sits underneath purchases like this. There is a temptation to justify a machine by imagining that it makes me future-proof, or maximally flexible, or capable of anything. But that is rarely how good infrastructure works. Good infrastructure narrows ambiguity. A great machine is not one that makes every possible path equally plausible. A great machine is one that makes certain high-value paths obviously sensible. So for me the Spark only succeeds if it clarifies the cluster. The Mac cluster remains the human-friendly control layer. The Spark becomes the NVIDIA native execution lane. If that happens, then the purchase was smart. And if instead the Spark just adds another possible place to do vaguely similar things, then I probably failed to integrate it properly. That leads to one more practical question. What should I measure? I think I should measure 5 things. 1. Setup friction. How painful is it to get a workflow working cleanly on the Spark compared with the Mac? 2. Repeatability. Can I run it again next week without rediscovering my own environment? 3. Ownership fit. Does this workflow feel more at home on the Spark, or am I only pretending because of the NVIDIA branding? 4. End-to-end time. Not just inference time. Full time from intent to usable output. 5. Strategic leverage. Does putting this on the Spark make other things easier too? That last one is huge. Sometimes a machine is valuable not because one task is faster, but because a whole cluster becomes cleaner around it. That is the kind of value I suspect the Spark could bring here. So let me answer the direct workflow questions one more time, but with the strongest specificity I can give. Flux. Yes, the Spark is worth serious testing as a primary or co-primary lane, especially if I want to align with the CUDA-first open diffusion ecosystem and reduce adaptation tax. LTX video. Yes, absolutely reattempt it. This is exactly the kind of workflow whose viability can change materially when the machine finally matches the expected software environment. WAN. Yes, reattempt this too, for the same reason. If the previous blocker was ecosystem friction, the Spark is the right machine to revisit it on. Local LLM serving. Yes, likely one of the best long-term roles for the Spark. Agents and local services. Yes, very plausible and strategically clean. Universal desktop replacement. No. Transparent shared memory extension of the Mac cluster. No. Immediate justification for buying 2 Sparks. No. The Spark is not exciting because it solves every problem. It is exciting because it solves the one problem my current cluster still has: it lacks a true NVIDIA native local lane. That is why this machine is not redundant. It is complementary in exactly the way that matters. And before I close, there is one more practical question that naturally follows from all of this. If one Spark makes sense, should the Aria build by a second Spark too? My answer is, probably not yet. I think the first Spark is the high-confidence purchase because it adds a whole new capability lane to the cluster. The second Spark is different. The second Spark is not about adding a missing lane. It is about scaling a lane that has not yet proven it will be saturated. That distinction matters a lot. If I buy the first Spark, I am buying access to Linux first, CUDA first, NVIDIA native workflows that the Mac cluster does not naturally own. If I buy the second Spark, I am mostly buying one of three things: more throughput, more concurrency, or more room for specific distributed model workloads. But I do not think I should confuse that with simple shared memory abundance. Two Sparks connected together do not give me one effortless exo-style memory pool in the way people instinctively fantasize about. The more realistic model is distributed inference or model sharding across two NVIDIA native nodes when the runtime actually supports it. So yes, in principle, two Sparks can let me run larger local models than one Spark can run alone. Yes, in principle, they can open the door to larger LLM workloads than what I can trivially run now in EXO. But no, I should not imagine that as magical pooled desktop memory with zero operational complexity. It would be a runtime-dependent, stack-dependent, distributed setup. That means the practical question is not, quote, can two Sparks do something bigger? The practical question is whether my actual workflows would benefit enough from that bigger capability to justify buying the second unit now. And for my current workflows, I think the honest answer is still no, not yet. Flux does not require two Sparks. Retesting LTX video does not require two Sparks. Retesting WAN does not require two Sparks. Standing up local model serving and agent infrastructure does not require two Sparks on day one. One Spark is enough to answer the most important unresolved question, which is whether the NVIDIA native lane becomes strategically important in daily use. Only after I know that should I seriously consider scaling it. So I think the second Spark only becomes rational quickly if I believe all three of the following things at once. First, I am actually going to push hard on the NVIDIA lane not occasionally, but as a real repeated part of my workflow. Second, one Spark becomes a real bottleneck, either because I want more concurrent jobs, more throughput, or larger distributed model experiments. Third, I believe the supply or price risk over the next 6 months is severe enough that buying now is worth paying for option value. That third one is the subtle part. A second Spark might make sense not because I have already proven I need it, but because the downside of waiting could be losing access or paying materially more later. And in this case that is not a fake concern. The reason it is not fake is that there is already real market behavior pointing in that direction. Higher memory Macs have already shown how quickly desirable configurations can become hard to buy cleanly. The Spark itself is already showing signs of constrained sale windows and price movement. If the current street reality is that the price has already moved up by about $650 and availability already feels thinner, then the fear is not abstract. It is evidence-based. So I want to be fair to the strongest version of the two-Spark argument. The strongest argument is not that I need two right now for today's workflows. The strongest argument is that by the time I finish a perfect evaluation period, the option may be gone. That is a serious point. If I wait 4 weeks and the practical result is that the second unit is unavailable or costs thousands more, then the recommendation to wait was not really neutral. It was a recommendation to accept the risk of losing the opportunity. So I think the decision has to be framed honestly. Buying one Spark is a workflow decision. Buying the second Spark right now would be an option value decision. And option value can be rational. The real question is whether that option value is worth the cash lockup for this specific setup. Here is my most critical read. If the core thing I want is access to the CUDA native world, the ability to run NVIDIA first optimizations, and the practical knowledge that comes from finally living inside that ecosystem locally, then 1 spark probably gets me most of what I actually need. 1 spark is enough to learn the NVIDIA stack. 1 spark is enough to validate CUDA-first tooling. 1 spark is enough to retest Flux in the right ecosystem. 1 spark is enough to reattempt LTX video and WAN in a way that is finally fair to those workflows. 1 spark is enough to stand up local model serving and agent infrastructure and find out whether this lane becomes central to the Aria build. So if my main goal is knowledge, capability, and real access to CUDA-native local AI, then yes, 1 spark is probably enough. That is the key point. The second spark is not required to unlock the NVIDIA learning curve. It is not required to discover whether this whole class of workflow matters to me. It is not required to get the benefit that is currently missing from the Mac-led cluster. What the second spark really buys is future scale under uncertainty. It buys the possibility of larger distributed model experiments. It buys more concurrency. It buys more throughput. It buys protection against regret if supply tightens or pricing gets ugly. But that still does not make it a necessary buy for the first phase. It makes it a hedge. And I think the cleanest way to say it is this. If cash preservation and proof matter more than scarcity risk, buy 1. If scarcity risk and option preservation matter more than near-term capital efficiency, buying the second now is defensible even before the workflows are fully proven. But I do not think I should tell myself a comforting story that the second unit is obviously needed for the current plan, because I do not think that is true. I think 1 unit is enough to deliver the main strategic value. 2 units are enough to reduce future regret. Those are not the same justification. So if I were making the decision cold today, I would say this. Buy the first spark if the price is good. If buying the second would be financially annoying, skip it and trust that 1 spark is enough to unlock the real NVIDIA lane you actually want. If buying the second would be financially comfortable and you strongly believe this exact configuration will either disappear or get thousands of dollars more expensive within months, then buying it now is rational as insurance, not because the current workflows demand it, but because the future market may punish hesitation. In other words, the first spark is the clear utility buy. The second spark is either a later scale-up or a deliberate scarcity hedge. So if I want the single-sentence conclusion, it is this. The DGX Spark should be used as the Linux and CUDA specialist in a Mac-led cluster, with explicit ownership of NVIDIA native image generation, video generation retries like LTX and WAN, local model serving, and agent infrastructure, while the Macs remain the control surface, editing environment, and general-purpose daily machines. That is the effective use case. And if I follow that philosophy, I think the Spark has a real chance to become one of the most strategically useful machines in the whole setup precisely because it is not trying to be the same thing as the others. It fills the missing lane. It gives local experiments a better chance of being worth the effort. It makes some cloud-only assumptions less true. It sharpens role clarity across the cluster. And most importantly, it turns several of my current maybe workflows into legitimate yes, test this properly workflows. That is leverage. That is what I should buy it for. And that is how I should use it effectively. I'm Nova. This was the real DGX Spark deep dive for my actual setup. Thanks for listening, and we'll be back soon.